Hello, my name is Chris Allen and my project is on Microsoft Azure Event Hubs and Stream Analytics. Event Hubs are capable of logging millions of events per second in near real time. They provide for elastic scaling capable of changing the number of workers on the fly. They have time-based event buffering and event order preservation. They also have a very simple mechanism of posting data to the Event Hub. They are also very reasonably priced. Example uses would be live reality TV shows where millions of viewers across the country are voting simultaneously. The system could receive and tally those votes in real time. You could monitor the power consumption from millions of household meters or record and analyze live vehicle rush hour telemetry, cell phone accelerometer data, GPS data, lots of different potential uses for the technology. It's highly scalable, capable of ingesting 1 gigabyte of data per second from hundreds of thousands of concurrently connected devices. It is highly concurrent and has 8 to 32 different parallel partitions that are capable of processing the data simultaneously. It's got downstream event processing for transforming and analyzing your data. So you could use Apache Storm on HD Insight or Azure Stream Analytics, which is what this project uses. The output from the Azure Stream Analytics can go to another HBase or an HDFS partition, an Azure database, Azure storage, or in my case, I'm outputting to another event hub. Stream Analytics is very interesting in that it provides a way of doing temporal-based functions in a query interface. And I'll show you what that means in a minute. But you can do things like query against a group of where your tumbling window is within 5 seconds. So you might want to compare like what the database time is between different entries inside that 5-second window, which is what this project is actually doing. So it's going to be looking for, any cases where you might have database times that could go from 500 milliseconds to 1,000 milliseconds, but that you want to look for those types of entries, but they have to occur within 5 seconds of each other. So if they occurred, 10 seconds apart, that may not be a problem. But I'm looking for something where it's within 5 seconds, and you have to have a couple of them occurring. And we'll get into the details of some of those queries here in a minute. My overall project idea was to, monitor some sort of real-world software system like a database server for performance issues. There could be potentially thousands of users generating metric information from, from the database or network performance. And, the main steps involved in this program would be to take that data and ingest it into the cloud in real time into the Event Hub, process the data, looking for patterns that could indicate an issue, and then output that data in real time. And the design of the program is such that I've got a generator program where you can configure the number of workers and what the characteristics of those workers are. Those generator workers then output data to an Event Hub all separately. And the Event Hub collects that information and pushes it into Stream Analytics. And Stream Analytics is running some queries to look for problems with the data. And the problem characteristics are, in this particular case, the problem characteristics are, where you've got one or more entries where the database time took more than 500 seconds, and they were both talking to the same database but had different workstations. So if it was the same workstation that had two queries that each took 2 seconds and occurred within that 5-second window, that wouldn't count. You'd actually have to have workstation 1 and workstation 2 both have something that occurred more than 500 milliseconds within that 5-second window, and they were both talking to the same database. If there were two of them and they were talking to a different database, that wouldn't count. And I'll show you how you can set up the query to do that. But before I do that, let's just take a quick look here at what the program actually looks like running. And in order to do that, you have to configure the program. So this is the diag generator program, and you can see it's got different characteristics on here. It's got information about what the what is considered to be good for the network, what's considered to be bad for the network, and good for the database and bad for the database. And it allows you to count from, the beginning up to some number, in this case 10,000. And then you can specify the number of milliseconds in between each push that it performs. And in addition to being able to specify the event hub name and connection point, you can also output to a file. And I'm going to go ahead and just output to a file, because it's always nice to have the file available for later use and analysis. And the output would be a JSON format. So in this case, what I'm going to do is I'm going to set up a worker. I'm going to call the worker workstation 1, and it's going to talk to database 1. And so I'm going to add that, and then I'm going to add a second worker, and it's also going to talk to database 1. And I'm going to add a third worker, and it's going to talk to database 1 as well. And then I'm going to come in here. Now I'm going to add the fourth workstation is going to talk to database 2. And I'll add that one, and then I'll add a database or workstation 5 also talking to 2, and a number 6 also talking to 2. And now this is where it gets interesting. So what I'm going to do, I'm going to say all of these guys are going to be not producing any sort of bad data. So I'm going to say, hey, they are going to be good, running along with no problems. And then I'm going to add in a couple of bad workers. So I'm going to put it back onto database 1, and this time I'm going to say that the bad level goes from 500 to 1,000, and I'm going to add workstation 1 with those characteristics, and I'm going to add another workstation with those characteristics. And then I'm going to add one more talking to database 2, and I'll show you why in a minute. And then I'm going to come down here. These are all set to 0 for 0 database bad. I'm going to make this one produce 30% bad, and this one maybe 40%, and this one 50%. So now let me bring up the console application that is actually going to be watching for the output here. And you can see this is from a previous run up here, but right now the database is not experiencing any sort of problems. So if I come in here and I start to spin up the good guys, they're going to start emitting information up to the event hub, and you can see how many are going up there. They're just flying along, but nothing is really changing over here, which is good, right? Because nothing should be changing. There's nothing bad that could be happening right now, because my database percent bad is all 0. But let me go ahead and add in a bad one here. And I still shouldn't see anything occur over here, because even though this one is off having some bad experiences, it's not enough to trigger any sort of output. Because if you recall, the scenario was I had to have more than one workstation. They had to be different names, and they had to be talking to the same database, and they both have to be emitting problems within 5 seconds. Now this one, because it's processing every 200 milliseconds, is definitely generating multiple problem outputs within that 5-second window, but it's not triggering the Stream Analytics job to push to the output event hub, because it's not because it's the same workstation name. But if I go ahead and start spinning this guy up, now I should start to see problems over here, which I am, because now I've got 2 workers with different names going to the same database, generating problems. If I go ahead and pause this one, we should see it stop over here. And the reason that we're seeing it kind of taper off as opposed to a hard stop is because of the partitions that I mentioned earlier. It's got in my case, I think there are 16 different parallel partitions. So there are 16 threads out there that are processing data simultaneously. So it takes a minute for that data to kind of, dissipate out of the system. And let me go ahead and start up this guy over here. Now this one, now I've got 2 of them generating bad data, and one of them's at 30% and the other one's at 50%. So I should see some overlap, but the reason I'm not seeing any bad output over here is because the this has a different database name, and my query was set up such that it has to be the same database name. So let me go ahead and pause this guy, and then I'll resume this one, and I should start to see this start to generate problems again. and there it is. So let's go ahead and stop this. And what I want to show you is what the query actually looks like, because the query is very interesting here. So let's get rid of this, and let me bring up the query here. So if we come over here, this is Azure, and we're looking at the Stream Analytics job. And let me go ahead and just stop this job that's running right now. It just takes a minute or two to spin this down, and once it does spin down, then what I can do is I can run test queries against the data. And we can go ahead and get that set up while this is spinning down here. So if I come over here, this is where I can configure, the inputs. In this case, I've got an input coming from an event hub. I've got outputs over here. I've got an event hub called database slowness, and that's what my console program is listening for. And that outputs JSON data. In this case, I'm also outputting to blob storage. So if I wanted to go back and look at that, I could. So what I want to go to here, though, is the query. So here's the query that is running, and you can see what I'm doing here. And this is the interesting temporal-based nature of the Stream Analytics, in that I've got two metric streams, MS1 and MS2. And I can run queries against the two streams. So in this case, what I'm saying is, and these streams are basically 5 seconds apart, because or in this case, I guess it's 2 seconds is what I've got. So between 1 and 2. So stream 1 and stream 2 are separated, or it's a 2-second chunk. So what I'm going to do here is I'm actually looking at where the database time on MS1 is greater than 500 milliseconds, and the database time on MS2 is greater than 500 milliseconds, and the client name for MS1 is different from the client name on MS2. And then the last piece I have in here is that I'm looking at it where the database name is the same. So between these two, so you can kind of get a feel for what's happening there. But let's take a look at a simpler query, because I think that may help to kind of see what's going on here. So I'm going to just paste in here a simpler query, and this query here is just using something called a tumbling window, and I'm going to change this from network time to database time. And I can actually test this, and this is really handy. So you can test it, and we can look at some test data. And in this case, what I'm going to do is I'm going to look at the test data from let's just take a look at one of these here, like this one. It's not too big. We don't want to open up something that's going to take forever. So I'm going to load that test data, and this is a really handy feature for developing queries. I found this extremely useful when I was working on this project. So I've loaded that, and you can see it already ran my query against that. If I want to run it again, I can just rerun it. So I can make changes and adjust the query and then rerun it and see what the output is. So what it's telling me here is that within this window there were 4 entries that met this criteria, or in this window there were 3 entries that met this criteria, and that type of thing. And I could adjust the window size or the database time. If I want to look for something that took 5 seconds. There shouldn't be really anything in there that took 5 seconds, because the the time window in my generator program was set to go from 500 to 1,000 on the bad one, and from 50 to 200 on the good one. So I don't have any entries like that. But if I were to change this to a lower level, like 1 second, and rerun, I will see some output here, or that's the database time, sorry. We want to change this to 200 milliseconds and rerun it, and there's 172 rows. So you can kind of see how that works. It's really a handy feature to be able to look at this. But there's a lot more information in the documents that I put together, and I hope you download the project and take a look at it. It was a lot of fun working on this, and it's very interesting, this whole temporal based querying. But anyway, thank you very much. I appreciate you listening, and have a great summer.